All right. Welcome back, fellow cryonicists and all the cryo-curious and everybody else. Today we are speaking with the world-famous Aubrey de Grey, biogerontologist, godfather of anti-aging life extension research, founder of the Lev Foundation, SENS, and now, of course, the Longevity Escape Velocity Foundation. Aubrey, welcome to the show.
Well, thank you very much for having me.
Is there anything else you would like our listeners to know about your background before we begin?
Oh, I don't think so. I think my background is fairly easy to look up if you're so inclined. But you've certainly said the things that matter the most.
Great. Yep. And our audience is quite likely to be familiar with your work, as you can imagine. In fact, we recently had a survey of cryonicists where we asked them like almost 100 questions, but one of them was how many of them are also life extension enthusiasts? And a majority of them are. So about 54% consider themselves a complete life extension enthusiasts as well as being cryonicists, which is incidentally more than any other category in cryonicists, more than rationalists, effective altruists, futurists, transhumanists. So all of those categories pale in comparison to life extension enthusiasts. So like I said, people will be familiar with you if they are certainly in that space.
I'm actually quite surprised that the percentage is as low as 54%. We expected that almost all cryonicists would be interested in, not dying.
Yeah. It could be. And we'll get into some details of that. But for example, it could be that they were life extension. Many more of them were life extension enthusiasts, and then for some reason lost their confidence in being able to reach longevity escape velocity in their lifetimes, and so now they're signed up for cryonics or such. But we'll get into some of these details, as you could imagine. But I would say that cryonicists and the cryo-curious, or the cryocrastinators, as we call them, which are our audience here, we certainly have the same shared goal as people who are interested in life extension, which is the goal of indefinite lifespan or sticking around, not dying of aging and age-related disease, and instead, being able to choose how we decide to go someday, if we do decide to go someday. So sticking around for the long term. And so with that goal in mind, I do want to make sure that our audience is familiar with everything that you've been doing in the life extension field. So Daniel, did you want to take it away a little bit?
Yeah, I want to make sure we're all caught up, and as Max said, we're all pretty familiar with the field, but we kind of want to know what's been happening lately. The majority of our audience will know what you've been working on in kind of broad strokes, but for the people who are new to this space, could you provide a very brief overview of your work on aging and life extension, and maybe a short primer on the 7 types of damage that the body accumulates?
Yeah, sure, I can tell you that. So, I guess the main thing I'm known for regarding the biology of aging is that in the year 2000, I had a kind of eureka moment and realized that there was a case for a really profound paradigm shift in terms of how we think about the feasibility and the process of bringing aging under medical control and keeping people from getting sick when they get old. The paradigm shift was quite simple to describe. It is simply that the best way to do this may be to repair the damage that the body does to itself throughout life in the course of its normal operation after that damage has been inflicted, though before it gets to a level of abundance that actually makes us sick. And this was in contrast to the previously prevailing paradigm, which was that the way to postpone the point at which we get sick would be by making the body run more cleanly. In other words, making it generate this damage more slowly than it naturally does, as opposed to repairing damage that's already happened. So it turns out that this approach of damage repair is indeed a lot more feasible, at least when we want to do it in a big way. But that doesn't mean it's easy. Otherwise, you wouldn't be needing to speak to me anymore, because we've been trying to get this to actually be implemented for quite some time. And of course, it's rather difficult because the body is a really, really complicated machine that inflicts a lot of different types of damage on itself in the course of its normal operation. So actually, I try to avoid these days using the word types of damage, because there are two interpretations of that, and I don't want to confuse people. So I talk about categories of damage, of which I am still saying there are, for practical purposes, 7. And then within each category, there are examples of that category. So, for example, we can take cell loss. That's one of the categories. And it simply means cells dying and not being automatically replaced by the division and differentiation of other cells. And that's an important category. And it has various examples prevalent in age-related ill health. One of them is Parkinson's disease, which is caused by the loss of a particular type of neuron. And another one is decline in the immune system, which is partly caused by the loss of cells in an organ called the thymus. One type of problem with the heart is the loss of a particular type of cell called pacemaker cells. So you can see that there are a bunch of examples. And the question that, of course, immediately arises is, well, so what's the utility of grouping these many, many examples into these 7 categories? And the answer to that is simply that the method of damage repair is likely to be generic. In other words, that you may do somewhat different things to repair each of these types of damage within a given category, but the the damage repair approaches will have a lot in common. So in this case, broadly speaking, we're talking about stem cell therapies or variants on that theme, things that make cells more stem-like, make more stem cells of the relevant type, so they can do things. And so that may be a case of directly injecting the stem cells in question into the relevant place. That's actually already in clinical trials in the case of Parkinson's disease. It may sometimes be a case of using growth factors to make cells that are already present but are not behaving like stem cells, make them more regenerative. So in the case of the thymus, that's been done, again, in a small clinical trial already, the TRIM trial, led by Greg Fay. You get the idea. There's a lot in common between these things. You can use the same generic approach for a bunch of different examples within a category. And that applies to all the other categories as well. So, I could go through the categories, but that would be boring because, everyone's got that idea. So fast forwarding, what have I been doing over the past 23 years since I had that idea? Well, initially, of course, there was a lot of work to do to persuade my colleagues within the expert community that this was actually a good idea. And it's a big paradigm shift. So I'm fairly pleased that only took about a decade. That's fairly fast by the standards of these things. But then, of course, there's the minor detail of actually implementing all of this. And most of these damage repair approaches that I put forward in the early years of the 21st century are actually pretty tricky to implement. Some of them have become less tricky as time's gone on, the best example being the elimination of senescent cells. This is something that back in 2000 or so, I was fairly sure we would need to do using what's called suicide gene therapy, which is an elaborate and quite, advanced way of using gene therapy to do stuff. But of course, now we have found that there are drugs, that there are small molecules that can rather selectively eliminate senescent cells. And so that has, become a lot easier than it looked as though it was going to be. Actually, the same, of course, applies across a number of other strands of sense. So, for example, the case of stem cell replacement that I just mentioned, you've got, in general, with stem cell therapy, the same problem that you have with with organ transplants, namely rejection by the immune system, which recognizes the introduced stuff as foreign. And we now have this wonderful concept called induced pluripotent stem cells, which give us the ability to take cells from the person that we are eventually going to treat and manipulate them in various ways and make the cells we want, the cell type we want, from their own cells, so that when we eventually inject them, they will not be rejected. Of course, there are other things that have happened over the years that have very widespread applicability across medicine, but are very important for damage repair in aging. CRISPR is another great example, of course. So that's been happening over the past 2 decades. And at Sense Research Foundation, which I led for a decade or more, the goal was to develop especially the more challenging, the more difficult areas within Sense, such as, for example, the combating of mitochondrial mutations. Very tricky thing to do. But now, at Lev Foundation, I've got a somewhat different focus. We will, I'm sure, be doing things that are, again, along those lines, developing individual damage repair approaches. But one thing that we're focusing on right at the beginning is combining approaches, not necessarily approaches that we've developed, but rather approaches that anyone has developed, and that have been shown individually to have some effect on actually increasing lifespan in mice, both maximum and mean lifespan. If there is a modest effect in that regard, and especially if there's an effect when the intervention is initiated when the mice are already in middle age, then that's very promising. It shows that, we're on to something. And so the goal at Lev Foundation of our flagship project, which is just beginning now, is to combine such things to see whether we can get synergy, see whether we can postpone lifespan a lot more. So that's my current main focus.
And that's what you call robust mouse rejuvenation, that intermediate goal.
That's right, yeah. Robust mouse rejuvenation is a term that I coined a long, long time ago because I wanted to give a kind of numerical, quantitative milestone that we should be aiming for to get people really excited and really to convince people that aging is a medical problem and it's a feasible medical problem that we can actually make some progress on. Because, of course, there's a huge prejudice against that in society, the idea that aging is not really a disease at all. It's not like it's kind of off limits to medicine, which is crazy, but it's very entrenched. And so the only real way to fix that is by data. And yes, so I basically define robust mouse rejuvenation to be taking a bunch of mice that are, first of all, they have to be of a normal long-lived strain, not an accelerated aging strain or anything like that. Secondly, we wait until they're already in middle age so that they've got about a year remaining in their expected lifespan, in their average lifespan, and maybe more like 1 3/4 years for the maximum lifespan. And then we add a year to both of those numbers. In other words, we increase their mean and maximum lifespan by another year. So that typically means for a typical mouse strain of this type will live for maybe 2.5 years. So we start when they're 1.5 years old or so, and we aim to get them out to 3.5 and maximum lifespan out to maybe 4.25. And of course, we don't know whether the experiment that we're just starting now is going to achieve that. But if it doesn't, we'll try with other interventions and we'll carry on going until we do. And even actually, when we do, we'll probably still carry on going and try to get even more. Because, well, 2 reasons, really. First of all, the rhetorical one I mentioned a moment ago, that the naysayers, the deathists, shall we say, will be it will be much more difficult for them to make their case, and there will therefore be a lot more enthusiasm for funding the work to get this working in humans. And secondly, of course, the scientific rationale that things that work in mice may also work in humans. Of course, they may well not work in humans, but they've got a better chance than things that don't work in mice. And actually, damage repair therapies, by and large, I believe, have a better chance of working in humans if they work in mice than irregular drugs, which have a very low hit rate.
Do you find that when you reach these milestones that these so-called deathists or skeptics, do you think they'll just move the goalpost?
It remains to be seen. People have been trying since the beginning of civilization to find ways to put aging out of their minds and get on with their miserably short lives and make the best of it, rather than being preoccupied by, this terrible thing that's going to happen. And so, there's a lot of work to do to overcome that. But at the end of the day, first of all, we don't have to persuade everybody. We just have to kind of, shift the center of gravity a little bit of the debate. And that's already happened, but really unrecognizably over the past 20 years compared to when I started, finding out how desperately people wanted to believe that aging was either, a completely off limits to medicine phenomenon that was woven into the fabric of the universe, or else that it was a blessing in disguise in some way, or both. I think the conversation has become a great deal better over the years, largely as a result of the progress that's already been made in developing ways to postpone aging, at least in laboratory organisms.
Is there if that's a halfway goal, if that's an intermediate goal, the robust mouse rejuvenation, is there a quarter goal? For example, reptiles or fruit flies or something that we could do the same thing to prior to getting to the mouse?
I don't think so, actually. I think, if you want to work in organisms that are further away from humans than other mammals, such as mice, then you have two problems. First problem is scientific. In other words, basically because the body plan is different, the biology is so different, you honestly have a very much lower likelihood of achieving success, even if you can see certain commonalities, certain, conserved genes. That's not really nearly enough. And secondly, people just aren't very interested. They're not very impressed by, fruit flies that live twice as long as they used to. The third one is actually a technical one, that there are plenty of things that we know we're going to want to do in humans that you simply can't do in a fruit fly, for example, like stem cell therapy. It's just not possible. So no, I don't think that's really the way to go. I think the quarter way is to do things in mice or in other mammals, but probably mice, but just less impressive things. So, for example, the individual therapies that we are combining in our big flagship experiment right now, those would count, I would say. Those would qualify as, stepping stones.
So, another related question I had here was how much of the research that in total needs to be done to get us to the points that you're describing is research that needs to be done within what could be considered life extension R&D versus being done outside by the big players, the pharmaceutical companies and the other, the Harvard whatever research center, et cetera?
Yeah, that's a great question. And certainly within academia, I often have to point out to people, especially youngsters who are wondering what area of science to go into or area of biology to go into, I often have to point out that just because something is not called it's not called aging research, doesn't mean that it's not relevant. In fact, these days, when we're talking about damage repair and rejuvenation and regenerative medicine, most of the relevant research is not called aging research. And, so you may want, if you're choosing, for example, whose lab to join as a PhD student, I have to emphasize, do not simply look only at groups where the professor calls themselves a gerontologist.
And how much, so then I'm assuming like as a percentage, probably the majority, like you said, the majority of research that's going to be beneficial for this field is actually not happening in what would be considered life extension. But just how much funding and how many people are we talking about? And I ask this because cryonicists are notorious for saying that there's just no funding and hardly anybody working in cryobiology or the cryopreservation space, et cetera. But in terms of life extension, how big was it back in the noughts when you were working at it originally, and how big has it become now, especially in the past 5 or 10 years, where there's been a lot more interest in the space?
Yeah, so, I mean, it's definitely grown a great deal. And that process really began in the early 90s when Cynthia Kenyon doubled the lifespan of nematodes. Because the way she did it was by finding a single mutation that had this effect. And that suddenly made it possible to do more hypothesis-driven gerontology than was possible before. And that brought a lot of new talent into the field, especially youngsters. So that was great. But the impact of regenerative medicine on aging has kind of been the same thing, but even more so. So you've got both in academia and in the private sector now a lot of people working on regenerative medicine in various ways, whether it's tissue engineering or stem cell therapy or gene therapy, and very much seeing that the application of their work to the biology of aging is not only clear, it's also a selling point. There's something that they actually will emphasize in a business plan, for example, or in a grant application. This is completely different from how it used to be. In the 90s or 80s, certainly, even mentioning the idea of doing anything about aging, as opposed to just understanding it, was something that was completely prohibited in a grant application. It was the absolute kiss of death. But now it's rather the opposite. You kind of have to do so, even if you don't really feel like it.
And in the past 5 or 10 years, right, the big crypto whales have gotten involved, funding anti-aging research directly, spinning out for-profit companies from the nonprofit foundations that used to exist when they finally found some way to be able to kind of tap into the for-profit wallet rather than just the sort of quote-unquote charitable donations that were going on before.
Well, yes, it's been very exciting. So let me actually stop you there for a moment and elaborate on that, because there's really been two step changes that happened. First one happened more like 6 or 8 years ago, when people who actually were not necessarily, well, actually they were not from the crypto world, but they tended to be geeks. They tended to be people from the tech world, though not all of them were. They were investors. They were people who actually wanted to make money eventually. They were kind of, somewhat humanitarian about it, as in they felt this was a noble cause to be supporting, but really they wanted to invest if they possibly could. But some of these people were really courageous early-stage angel investor types. Nevertheless, they were in a position to write bigger checks than what donors do, and so that certainly made a huge difference. And at Sense Research Foundation, we pivoted our business model, very sharply around 2016, 2017, to one in which we would spin projects out as startup companies as soon as we could get investors interested. And we did that half a dozen times. So that's all wonderful. But then the crypto situation happened more recently. Well, not exactly, because one of the people who came in 2017-ish was Vitalik Buterin, the creator of Ethereum. And he's been extremely generous and made a huge difference by the donations he's made. But he was very much a donor, not an investor. He's got plenty of other ways to make money, and he wanted to help philanthropically because he did see that even with the influx of private sector money, there was still plenty of vital components of the Sense portfolio that were definitely pre-investable and needed to be taken forward and not neglected. And he was initially pretty much on his own in terms of high net worth crypto people. But then in early 2021, that started to change. A few other people came in, James Fickle, Juan Benet, Jed McCaleb certainly was very important. So these people have, led the way. And of course, I have to absolutely highlight Richard Hart, who has not himself written any big checks, but he has done something that only someone like Richard, who is very much a larger-than-life character, could do. He has inspired his community of followers who are often called hexicans, because, of course, Richard is known as the creator of Hex. And they've come in and put enormous amounts of money, like tens of millions, into anti-aging research. So yeah, that's been a huge thing, and that's all been on the philanthropic side. But it kind of is going on hand in hand with the private sector side.
Is it safe to say now that there are billions in the life extension space now? That order of magnitude is what we're talking about.
Yes, that's certainly possible to say. Okay. At this point, of course, the biggest players are individually that size. So Altus Labs, for example, has received it is claimed $3 billion from Jeff Bezos. Evolution has received a commitment to $1 billion per year for 20 years from the Saudi royal family. Various others are in that league, in the 9-digit realm, if not the 10-digit realm. So New Limit is an example of a company started by a crypto person, Brian Armstrong from Coinbase. There's Retro, which was started by Sam Altman from Y Combinator. So yeah, we've got quite a few very large companies now.
And since you brought up these kind of big players and funded by these tech giants, we kind of hear about them peripherally, but I think a lot of people don't actually know what they're doing. Do you follow their work, and do you think they're being effective with their money, or are they focusing on the right or the wrong things? What's your opinion on them?
Yeah, so I'm as looped into these companies as they allow me to be. So I talk to Evolution quite a lot. I talk to some of the people at Altos quite a lot. Some of these companies are much more secretive. Calico, of course, is known for its secretiveness. They didn't even announce when their chief science officer stepped down last year. That only became public last week. It was like, it's a funny way to run a company, I think. But in general, the community does have, as I mentioned a moment ago, the advantage that even the people who want to make money are also quite, invested in the mission of bringing aging under medical control. And that has led, partly because of that reason, I think, to a much more collegial and more communicative ecosystem than you would typically see in something that has a big private sector dominance like this.
And to kind of help to summarize this kind of catching up process, I know you could talk for endless amounts of time about all the new innovations, but if you had to choose one or two of them, what in the last 5 to 10 years, maybe even more recent, what would you consider the absolute major advancements?
So something Cryonics may not be familiar with, but should be, that's going on in the space.
Yeah. Okay. Well, but what you just said, Max, kind of preempts what I was going to say.
Okay.
Because to me, the things that are the most significant are things that pretty much everyone has heard of, and largely because they do not apply only within the biology of aging, but they apply across the whole of medical research. So I mentioned already induced pluripotent stem cells, IPS, and also CRISPR. Another example would be AlphaFold, the software that has more or less solved the protein folding problem, which is one of the most fundamental problems in biology. So, these things are enormously valuable simply because they make things that were previously feasible but very difficult a lot easier. Still not easy, but a lot easier than they were before and a lot faster. Other than that, I think if we're looking at things that people may not have heard about, I can't really include Senolytics there either because that's quite a high-profile thing right now. But there are things happening all the time that are more niche. Development of, for example, ways to manipulate mitochondrial DNA. This is something that I've been interested in for a very long time, and there are new approaches being pursued now that are making a little bit of progress in solving that problem, in getting us to be able to do things like, for example, putting copies of the mitochondrial DNA in the nucleus in such a way that they actually work. There are also improvements in gene therapy. People are constantly looking for new vectors, new ways to get to make genetic modifications in cells in vivo. And often this revolves around ensuring that the DNA can actually get into cells in the first place. There are various new advances there. There are advances in cancer immunotherapy, which is an area that was very much, going nowhere for decades. And then about 1 decade ago, we had these two enormous breakthroughs, the development of CAR T cells and also the development of checkpoint inhibitors, which have essentially made cancer immunotherapy a real thing. Still got a long way to go, though. And in the past few years, one thing that's very much excited me is the ability to make the immune system better able to detect cancers. In other words, basically to uncloak them, to remove the systems that they use to hide themselves from the immune system.
Yeah, and so there's been a lot of progress, but obviously not all rainbows and ponies. So what would you describe as the major hurdle you've encountered in the recent past, or that's still a sticking point?
Oh, there's still plenty of those. It's not nearly as bad as it was maybe 5 years ago. So I mentioned mitochondrial mutations a moment ago. Even 5 years ago, I would have had to say that we've made very little progress in that area, but progress has definitely accelerated. A similar case is the stiffening of the extracellular matrix, the loss of elasticity that we see that contributes to hypertension in the elderly, for example. That's an area which essentially was getting absolutely nowhere for a long time, but then a couple of breakthroughs were made, and that's now moving forward better. But still, a long way to go for those two and for other things. And also, there's a long way to go in terms of the stuff that Lev Foundation is doing, the combining of these therapies. The reason we've decided to make this such a priority is because it really is very difficult to fit it into the incentive structure of either the private sector or academia. So it really falls to nonprofits that are funded essentially entirely by philanthropy to get such stuff done.
Thank you, Aubrey. That was a good summary of where life extension is, at least in the past 5 or 10 years versus where it was before that and where it's going to be soon enough. So I wanted to shift gears a little bit to the question of LEV, longevity escape velocity. So this was a concept, I think, pioneered by you more than a couple of decades ago now, right? But I was thinking about this actually in preparation for this conversation. And I was realizing that even though I've known about this concept maybe since you first put it out there, I've been a fan of this for a long time. That there were a couple of different interpretations that I found of LEV, and I was curious which one you prefer, or am I thinking about this the wrong way? So one would be that longevity escape velocity is a point, we reach it for a given age, for an average person of a given age. So one can say, if you are currently 25, you are likely to, or not likely to, reach longevity escape velocity before it's too late for you. But I realize that might be true, but it's not the most useful because it would be potentially more useful to talk about it from an individual perspective and say, even though you may be 25, longevity escape velocity may come too late for you, even though it might come at the right time for other 25-year-olds. In other words, if longevity escape velocity first manages to tackle some of those categories of damage better, the therapies that are developed for tackling some of those end up being somewhat better than therapies that are developed for other aspects of that kind of damage, right? Like you're saying, you're trying to create a cocktail that would try to manage all of them at the same time, but presumably you're going to do better on some and worse on others when those first therapies start getting released. And there's some of those categories of damage may contribute more to certain kinds of age-related disease than other of those categories. I mean, you take something like Alzheimer's, right? I think you've mentioned that would be the stem cell treatments that would essentially regrow neurons in the brain in the right areas that are losing those neurons.
That was Parkinson's, actually, but keep going.
Parkinson's, yeah, Parkinson's. Right, so some sort of neurodegenerative condition, and okay, so if you happen to be the kind of person that is not susceptible to Parkinson's, then you're great, right? The other therapies will prevent you from succumbing to other age-related diseases. But if you happen to be the kind of person who is susceptible to Parkinson's, and those therapies didn't manage to get there in time for you, you may be the same age as your peers, but oh well, you're screwed. If only you would have been susceptible to something that is being addressed well by longevity, by the therapeutics that are being released earlier on, you would have been fine. So, am I thinking about this correctly? That longevity escape velocity is kind of spiky in this way, right?
Yes, you are. But that's really not where I tend to focus, because the fact is we have no idea how soon these things are going to come along anyway, right? All of them may take longer or less time. We just don't know. And so whenever I give, timeframe predictions about how soon we're going to reach longevity escape velocity, it's always a probabilistic prediction. I say, we've got 50% chance of getting there in 15 years, for example. I think really the essential thing to also bear in mind is that since we're repairing damage, which is, of course, the precursor of the pathologies that eventually kill us, there's a lot of time that goes by between the time when we would want to be administering these therapies and the time that people actually get sick and die. There doesn't necessarily have to be a lot of time, but there typically would be. You would expect that people who will benefit the most from these therapies are people who are, let's say, 60 or 70, people who've got a good decade or two of life still left in them, so to speak. And, of course, as you say, that depends on what kind of personal weaknesses they have in their health. Some people may be more susceptible to one type of damage than another. But also, overall, some people are just aging more slowly than others overall, without picking apart the different mechanisms. So I'm not really too much thinking about that transitional period. I think we're going to get through it pretty quickly. I think by the time we've got to the point where anybody can get as much as, let's say, 20 years of additional life, we'll be very close to the point where basically everybody of that age can. So I don't really think too much. So basically what you say is true, but it's not my focus, really.
So this period of time where we have kind of partial LEV, right, where we've better addressed some of these matters than we have others. You think we're going to run through that period of time in a matter of years or a decade or two or something?
Oh, well, no, we will always be at a point where we've addressed some things better than others. But all of them will be moving forward, not in lockstep, but, in semi-lockstep, if you like. They'll all be moving forward. And so the question is not so much, will we get to a point where we're addressing everything equally well, but rather when will we get to the point where a given person is having his or her problems addressed fast enough so that their biological age is not increasing even though their chronological age is.
Right. So the point at which basically anybody who is interested in getting these therapies, no matter whether they're more susceptible to heart conditions or neurodegenerative conditions or whatever, right. The point at which it doesn't matter what you're susceptible to, you're going to be getting enough advantage of these therapies that those issues will not end up being your demise.
Right.
Yeah. Well, I do hope we run through this partial state. I hope it's not spiky, but it could be, but I hope it isn't. Anyway, so that was. I'm. Thanks for clarifying that. I always. I like to make sure we're all on the same page with something as big as longevity escape velocity as a concept. Daniel, did you want to take us on to the next?
Yeah. So kind of transitioning into your role in cryonics, because I think everybody's going to be particularly interested in this. For one, how long have you been a cryonics member, and with which organization?
Yeah, so I've been signed up with Alcor since 2002. Essentially, what happened was that Alcor ran a conference in Southern California in 2002, which they invited me to. I was only, I wasn't really very known by that, but in the wider world by that time, but I was somewhat known within the futurist community, and they asked me to come along and give a talk on longevity and science. And it was really my first exposure to cryonics. I had heard of it, but I didn't really know anything about it. I hadn't thought about it very much. I was immediately impressed by not just the logic of the concept, but by the work that was going on, the dedication of the people involved, and so on. So I didn't have any hesitation in signing up. And yeah, I've been very much a public supporter ever since. I think they appointed me as one on their scientific advisory board pretty much at once. So that's my cryonics story.
Okay, and so you're on the scientific advisory board. Did you have any other professional involvement with any other cryo orgs, or has it been kind of more of a background thing for you?
Well, it became much less of a background thing over the past several years. So that's largely because in 2010, shortly after I founded Science Research Foundation, I needed a chief operating officer, and I was able to recruit Tanya Jones, who has, of course, a very long and distinguished history in cryonics. She was the chief operating officer at Alcor for a long, long time, as well as the CEO for a short time. And she basically built my lab for me, and did a whole bunch of other good stuff. But after doing that for a number of years, she transitioned into leading a startup company called Aragos, focused on a very new technology for dramatically improving the quality of cryopreservation. And very much like 21st century medicine, the goal here is initially to address organ transplant problem, the shortage of organs by doing organ banking and such like. But definitely there is a cryonics dimension to it. So Keinice is officially a new company, but really it's a kind of reboot of the company that Tanya led for the past several years, a company called Aragos, which basically just ran out of money. And so we at Lev Foundation are seed funding the kind of Aragos Mark II. The technology that is being pursued here, and the reason why we're doing this, is a really, really exciting technology called helium persufflation. So basically this means using cold helium to pump through the vasculature, the circulatory system of an organ or a whole person, depending on what you're doing, and thereby to cool that organ. Now, the value of this is that the rate of cooling is enormously faster than the rate that you can get by cooling from the outside, from the surface of the organ, especially for large organs like whole people. Because basically you've got 3 dimensions to work with rather than only 2. So the surface to volume ratio, so to speak, is a great deal better. And that's really important for cryopreservation because, as most cryonists will probably know, the way that cryopreservation is done these days is by using a special, rather elaborate cocktail of cryoprotectants, which are used to prevent the tissues from crystallizing, from forming ice crystals. And instead, what happens is that eventually, of course, the tissue does solidify, but it solidifies as an amorphous solid, a glass. So this is called vitrification. So why is the speed important? The simple answer is that the cryoprotectants that are used are a little bit toxic. Only a little bit, but still. And therefore, the time that it takes before you get down to the temperature where basically chemistry stops, and therefore the toxicity stops, is critical. The faster you can cool, the less the time is, and that's great. On top of that, turns out that the faster you cool, the lower the necessary concentration of cryoprotectants. Because basically the cryoprotectants are there to prevent ice crystals forming that are big enough to cause osmotic issues and such like. And if you're cooling really fast, that basically just doesn't happen so easily. So you need less cryoprotectant. So this is huge. And on top of all that, persufflation has another really, really important selling point, which is it prevents cracking. So many of you will know that the problem with there's a big problem at the macroscopic level with cryopreservation of organs or people, namely that there are thermal stresses that develop as a result of uneven rates of cooling, which is basically unavoidable. And the thing about cracking is that it starts somewhere. A crack starts at a given point, and then it propagates. And cracks, small cracks anyway, just do not propagate through bubbles. So when they hit a capillary or whatever that is full of gas, the crack just stops propagating. So you can do cryopreservation using persufflation without actually having any fracturing of the sort that it's been so difficult to avoid over the history of cryonics. This is like, it's a huge breakthrough. So the real innovation, so persufflation per se is not a new idea with Aragos or Keinice. It's been done for a while, but there's one enormous innovation that that Tanya and her erstwhile colleagues, Lev Van Sickle, introduced, which is certainly new and which is particularly relevant to cryonics. Namely, they use helium as the gas that is pumped through the circulation. Helium is really good for various reasons. The main one, as I understand it, is that it has very low solubility in water. So you don't get, the kind of you don't get the equivalent of the bends that you get with nitrogen.
And you said that the previous company that she had was Aragos, essentially ran out of money. So why would this one, and now this one, of course, has new seed funding from you or from others. Why would the same thing that happened to that one not happen to this one? What is?
Well, of course, first of all, Tanya, has learned from various mistakes that she may think she's made over the past few years. So it's just a matter of getting to proof of concept, right? Once one has reached a certain point, then it becomes progressively easier to bring money in.
And what is the first organ or the first proof of concept that she's hoping to succeed at?
So, there's various options here. So the initial work at Aragos was mostly done was all done with kidneys. Kidneys are quite, a sensible organ to use, not least because they're the organ that has been most explored for organ cryopreservation among solid organs by other people over the decades. But then, towards the end of Aragos, she moved on to hearts, which it seemed the process seemed to be working even better than for kidneys. And then there's also other options. So I can't necessarily talk too much about the details of this, but there may be ways to actually get initial products and therefore revenue using things that are not just whole solid organs. There are various potential options for research and for medicine that may be easier to get to.
And is Keinice starting with mice and mice organs again? Just
actually, no. So one curious thing, which is very handy with regard to persufflation, is that it works better for large organs, completely contrary to what's going on in regular cryopreservation, where you've got this, it's much easier to preserve smaller organs because of that rate of cooling thing I mentioned earlier. That doesn't apply when you're pumping stuff through the vasculature, because the vasculature is everywhere in the organ, within the organ, whatever. Actually, no, they've been working with pigs all this time.
Yeah. And I assume that kidneys are also a good option because part of the kidney can be not functioning very well, and still you can get a sufficient amount of functionality from the kidney that it's able to be used in another animal. Versus a heart, where if a fourth of the heart is not properly, then you're not going to get any functionality.
Yeah, that's true. Of course, that's also true of other organs like the liver. But what's additionally true of the kidney is you've got two of them. So you can, for example, do a transplantation experiment. You can actually take one kidney out of a pig, and the pig doesn't have to die, and you can freeze and thaw it and put it back into the same animal, and then take the other one out that has not been treated, and see whether the one that was frozen and thawed can support the animal.
I would say, insofar as the organ of the heart, I know from what I understand, there's actually a very short window of time for heart transplants, in between which a donor can provide the heart and it can actually be transplanted properly. And correct me if I'm wrong, it's something like 2 hours. Maybe I'm exaggerating there, but that would be. Commercially, that seems like it would be a massive boon if proper cryopreservation of the heart could be available. What organs do you think are the most kind of commercially viable or are going to be the biggest market?
So basically, all solid organs that are whose failure is fatal and life-threatening are in this bracket. So certainly not just the heart, but also kidneys and livers and so on. All of these organs have a very short time that they can survive and remain viable. It varies from organ to organ, but it's on the order of hours for all of those organs. And so absolutely, that is the main reason why there is currently such a tragic organ transplant shortage, and why people, all the time are dying on waiting lists, waiting for someone to die nearby who is sufficiently immunocompatible that they can have their organ. And so, if you could bank these things, then, that is absolutely astonishingly important in terms of saving lives. And that, of course, is not a new idea with Keinice and persufflation. This is precisely the business model that 21st century medicine, run by Greg Fay, has been pursuing for decades.
And given that there's such a or it seems like there would be a larger commercial demand for this in the past, why does this kind of technology still have on the order of a tiny amount of money, given how useful it seems like it would be?
Well, I think that's kind of the same reason why cryonics in general doesn't have much money, that there's a credibility gap. People have known that the most ardent and skilled researchers working on the cryopreservation of solid organs are also thinking in the back of their minds, if not the front, about cryonics. And cryonics obviously has a huge reputation problem within the mainstream community because they just don't like the idea. So I think that's a large part of the reason people have, shied away from it. A lot of people who might have been able to make contributions to progress in this area over the past 10, 20, 30 years have just not gone anywhere near it because they want to do things that are less adjacent to cryonics.
So as soon as you start discussing the cryopreservation of anything larger than an embryo, suddenly everybody starts running for the hills and saying it's impossible, it's never going to happen?
Pretty much, yeah. I mean, of course, it depends on the circumstance. If you're working with, nematode worms, which are larger than an embryo, or larger than an embryonic stem cell anyway, then that's fine. And if you're talking about things that can be flash frozen in whatever way, because they have a large surface to volume ratio or whatever, such that cryoprotectants are not even needed, then this is the kind of thing that has been routine in the laboratory for a long time. But once you get on to research in this kind of area, it's a different matter.
Are there any substantial roadblocks besides funding or anything like that left for Tanya Jones and for Keinice to be able to move forward?
It's early stage research, right? I mean, it's got some basic proofs of concept milestones to actually reach before it really is self-sustaining, so to speak. One's got to actually show that one can cryopreserve a pig kidney, for example, and do that transplantation experiment I described. These are things that may not be very far off, but you never know with research, do you? How long it's going to take?
Yeah, but of course, as soon as she's able to cryopreserve a pig kidney, then the spigots will open and the flows of funding, I imagine, will come pouring in specifically for organ banking and that sort of thing.
I think so.
Yep. So moving on to a sort of a related subject, but Daniel and I were having a conversation last week now about the kind of a crossover between life extensionists and cryonicists. So it seems to us that a lot of people who are interested in life extension are interested in life extension because their goal is to prevent people from having to die of natural causes, from having to expire given the clock that evolution has deemed fit to grant us. And cryonicists want the same thing. We don't like the idea that aging and other natural processes are going to take us prior to us making that decision ourselves or our loved ones or society in general. So we're both interested in this ability to unlock an indefinite healthy lifespan, both cryonicists and life extensionists. So why is it that it seems to me like there are so many more people interested in life extension than there are people interested in cryonics? Even the number of people interested in life extension, the ones who then go on to become cryonicists or even say that it's a good idea, seems to be relatively small as a proportion of all of those individuals. Can you shed some light on this?
I think so, yeah. I mean, I don't think it's very hard to explain, actually. The thing about cryonics is that in order to believe that it makes sense to be cryopreserved once you become legally dead, you have to feel that it's reasonably plausible that rejuvenation technology, the kind of thing that life extensionists mostly think about these days, will eventually be so sophisticated that it can take someone who was so sick that they were declared legally dead and fix them up and make them healthy again. And of course, we know that the first generation rejuvenation technologies are not going to be that good. They're going to only really work for people who've got, a number of years left in them so that they can, benefit from these therapies. And over time, the therapies will become more sophisticated and less invasive and so on, such that we will be able to rejuvenate people who are progressively closer to death's door, so to speak, and eventually beyond death's door, at least where death is defined legally. But that's that's looking a long way into the future. And a lot of people who are in this field don't think that far ahead. They think in terms of 10 years of additional healthy life is well worth having, right? And so they're very into the research that's being done to keep people healthy whose hearts are still beating. And they don't think, all that far beyond that. And I think that's reasonable. I'm not surprised at that.
So it's just that they're I hate to put it this way, but short-sighted. I mean, they're not considering
I wouldn't even think of it that way. I would say it's a matter of taking one step at a time, and in terms of what they focus on. So I would suggest that if you take someone who is very into what a typical person is very into what people like myself are doing in rejuvenation, and who feels that there's a chance of significant progress, like 10 or 20 years of postponement of the health problems of late life happening in the next couple of decades, if they think that, then if you actually ask them about cryonics, about, and you present it as a kind of logical extension of healthcare in the context of progressively improved rejuvenation, then they probably won't push back very much. But that doesn't mean it's sufficiently front and center in their minds that they'll actually sign up for a policy.
Is it just that the goal, the sort of shared goal, doesn't seem to be as shared? Because so what you're describing is that they have a sort of a different goal, right? Yeah.
Yeah, I don't think it's a different goal. No, I think it's the same goal, but it's not one goal. It's not. It's a kind of smeared out goal. I don't think about how long I'm going to live or how long I want to live. I think that's a crazy thing to have an opinion on, to be perfectly honest. I think that the right thing to have an opinion on is whether you're ever going to want to get sick. And, I'm fairly sure I don't. I'm fairly sure I won't ever want to get sick. So, I'm just investing time in making sure that I maximize the chance that I won't have to get sick however long ago I was born. And that's kind of, I think that's the reasonable way to think about that. But if you think about it that way, you think about it as like something that you're always going to want, a kind of, proof by induction kind of thing, then it's like, it's a kind of a subjective thing, really. How much you focus on the first 10 years, 20 years, and how much you focus on the getting to 1,000 or whatever.
So just going through my own story about how I came to this. When I was in college in the early 2000s, the first half of 2000, undergrad, I became interested in your work and all the stuff that was going on. And I said, okay, that's great. Life extension is a thing that's going to happen. It's going to happen well within my lifetime. And so, great. I'm already not going to have to succumb to diseases of old age and all the problems that come with that and having to check out before I'm ready to check out. And I said, great. So I kind of pushed that off. But then, maybe a decade later or so, I started to think, well, there's been progress, but not as much progress as I would have liked. And so I'm going to sign up for Cryonics, in a way hedging my bets, but in a way also acknowledging that I could be, hit by the proverbial bus tomorrow, and hopefully not hit on the head very hard. And even if life extension happens to get here well within what would have been my natural lifetime, something could happen. I could suddenly develop cancer, and it's statistically unlikely, but it happens, or whatever. And if I'm sufficiently interested in that end goal, why not sign up for Cryonics while also seeing whether or not these technologies pan out, given your efforts and the efforts of so many in that space?
For me, that comes down to the probabilities that you just mentioned, right? So people often think, okay, so there are various things that I could avoid doing or I could do that would lessen the chance of some particular near-term cause of death that's already very unlikely, right? But most people don't do that. In fact, basically nobody does it. Everyone who gets in a car knows that they are at greater risk than if they don't get in a car. One has health insurance, of course, but insofar as having a cryonics policy is just another type of health insurance, which I think is the right way to think about it, because it's what risks are you insuring against? I think, if it's risks that are, first of all, unlikely causes of death, and especially if one takes into account the very much less impressive quality of cryopreservation that one can reasonably expect in the case of traumatic death rather than death that you actually anticipated, then, one can argue with some reasonable justification that it's not worth the money in today's world. There are just too many other things that you can die of that, a cryonics policy won't help you with.
Of course, somebody making that argument, just to jump in here, Daniel, somebody making that argument, especially when they're young, would have access to very inexpensive life insurance policies that would grant them access to cryonics, whereas So it's almost like the equation is, yeah, sure. When you're statistically unlikely to have one of these fluke events happen and kill you, it's also incredibly cheap. And then when you're statistically far more likely to suddenly, get diagnosed with some sort of cancer that is very aggressive, then the policy has become very, very expensive and it's more difficult.
Yeah, I mean, I think most people, have some degree of irrationality about that, whether it's at the level of simply, not really getting into their heads that this is paid for by insurance and therefore thinking that it's prohibitively expensive, or whether one's in the state of just denial, just not really thinking that cryopreservation has a sufficient chance of working at the moment, and therefore, what's the point? In other words, forgetting that by the time you're likely to die, cryopreservation will be of higher quality with a bit of luck. All of these things are there in a lot of people's minds. So, and I'm not saying anything new here. I mean, obviously, these are questions that have been asked and answered a million times by cryonicists over the years.
Yeah, I was going to say something, along the same lines of Max. I mean, I don't consider it just a little bit irrational when we're talking 18 to 25-year-olds with life insurance. This is dirt cheap. There's really no good reasonable way to even with the extremely low risks to not take advantage of this. And yes, you're absolutely right that a lot of these people don't actually know life insurance is available. So I think that's kind of often where I start when I'm talking to people is asking them how much they think cryonics costs, and then jumping right into that just so they're aware that this is something they could do. But even after that, it still becomes difficult. I mean, and I'm always surprised because the risk reward ratio for indefinite lifespan is just unmeasurable.
That same argument can be applied in a lot of places around what people do with their money. I mean, let's just take an average kind of life insurance premium. So I signed up when I was 40, and I pay, I think, $40 or so, $50 maybe per month. People could pay my foundation $50 a month, and they'd probably make more of a difference to the chances, because they hasten the research that will keep people alive before they become legally dead. So the same applies across the board, really.
They should really do both, Aubrey.
Well, sure.
Yeah,
kind of knew that.
I would say it's not. I don't think. I think cryonics and life extension should go hand in hand. They should be coupled. I'm curious why when you're at conferences, why when you're talking to people, do you not talk about life extension and then add a brief caveat at the end about sign up for cryonics just in case?
Well, I kind of do. I mean, I run a lot of conferences, remember, and I always have cryonicists speaking. So it's pretty front and center compared to. I mean, there's a few other gerontologists like Aubrey de Grey, for example, who do the same thing. There's only so many things you can put into one talk, but and you want to kind of have some degree of focus on talks. But I give talks at cryonics conferences as well, of course. So it's not as if I'm ashamed of it or anything. Yeah, I mean, I think the really important thing, I think the best way to frame it is to say, listen, cryonics, signing up to be cryopreserved is a form of health insurance. Once people start to think of it as a form of health insurance, then everything else kind of becomes a lot easier to explain and to justify and to promote, really. Of course, there is the downside that once it becomes health insurance, it ceases to be life insurance, and life insurers won't pay out.
That sounds like a good problem to have, I think,
Well, I don't know. I mean, it will eventually be a good problem to have. But yeah, we wouldn't want too many life insurers thinking that way quite yet, I think.
In a previous talk, or it might have been another podcast, you had mentioned how mainstream researchers if they started to take life extension seriously, and people like Oprah started pumping life extension, that there would be this sudden overflow of interest. If that were the case, how much of that overflow do you think would trickle down to us mere cryonicists?
I think it would be simultaneous. I mean, yeah, I would call it more of a tidal wave, and we're very close to it now. Let's be clear, we're very close to it now. The kind of things that other very, completely mainstream credentialed researchers say, the similarity to what I've been saying all these years is getting quite high. And so, no, absolutely. I think, I've been telling people for quite some time that if they want to make serious money out of life extension, a big thing that they could do is invest in companies that make duos. Because I believe that if as and when the idea that we might soon be able to stay healthy indefinitely catches hold, the idea that we should improve our chances of getting there via cryopreservation becomes a very great deal harder to just laugh away, to just dismiss for irrational reasons. So yeah, I'm completely sure that these things will be simultaneous.
And do you think the ratios will stay the same in terms of the total number of people interested in life extension versus cryonics when this happens?
Sure, I think so. I mean, I think, anything that multiplies the number of people interested in life extension by 1,000 would totally be likely to multiply the people interested in cryonics by 1,000 as well.
Okay. And insofar as cryonics by itself, not as just the kind of the sidekick of life extension, what do you think would have to happen in cryonics to create a similar influx of popularity that I guess life extension is even just experiencing right now?
Well, not a lot, to be honest, because the main reason why one would still, with some degree of rationality, say, there's no point in signing up. At that point, if one had basically completely taken on board the idea that rejuvenation is here, or it's almost here, right, I guess there's two answers. One is that to feel that even though rejuvenation is here, or almost here, there's going to be some kind of diminishing returns on that, such that we're never going to get to be able to rejuvenate people who are so sick that they've been pronounced legally dead. And that's something that can only be challenged by digging into a lot of details about, what kinds of damage accumulate in the body in the first place and so on. It's not as stupid an argument as all that. And the second one is the idea that the quality of cryopreservation is never going to get good enough. So I think it is certainly reasonable today to be quite pessimistic that anyone who has been cryopreserved yet, however close to the ideal given today's technology, is revivable, as in has had a small enough amount of damage done to them. Of course, this depends on whether one views revival by uploading as bona fide revival, and that's obviously a philosophical spectrum there between people who are into cryonics. But if one doesn't, if one's only talking about being revived by being warmed up and rejuvenated, then one could take the view that it's just not going to get there. So that means that for sure we need to make progress in things like persufflation, but it also doesn't necessarily mean, any more than it does in rejuvenation, that we need to get all the way. If we've got far enough that we can, freeze and thaw a kidney or a heart, then even if we haven't yet done it for a brain and shown, cognitive function in a monkey, for example, then if that turns out to be quite a lot harder, the question is how much harder? Is it harder enough that it still won't be done by the time you need it if you're not going to die for a couple of decades, kind of thing. So yeah, I mean, these are the kinds of twos and fros that are going to happen at that point.
I want to push back on one thing, Aubrey. I'm thinking back to the post that was made by Tim Urban, Wait But Why fame, on Cryonics, where he describes that he made a very simple little graphic where he describes that it's essentially going to be LIFO, right? So last in, first out, right? So the last people who are cryopreserved are going to be the ones who get the best cryopreservation, presumably, and they are the ones most likely that the technology will first catch up to them, before it catches up to all the people who had worse cryopreservations. And of course, you could also factor in, like you were describing, the amount of damage that person has sustained before being cryopreserved at all. In other words, how much have they aged and how badly degraded their cellular structure and everything else is. But you said before that people worry that we would never get to the level of technology necessary to be able to revive somebody who is cryopreserved at a given state. But never is a very long time, right? So I imagine that as long as nothing happens to your doer, like, as we both know, you're chemically on pause. Nothing is changing whatsoever. So it could be that even if you have a rather poor cryopreservation, I don't know about a straight freeze, but let's just say far from optimal cryopreservation, and you were in your old age when it was done, that it just means you have to wait a great deal longer, but you will eventually... The technology will eventually catch up to that, right? So it could be another 100 years, it could be another 1,000 years, and sure, that increases the statistical likelihood that something will happen to your body in the meantime, whether it's something that falls out of space and destroys it, or a fire, or the company going out of business, or who knows what happens. But it just seems to me like this idea that the concern that a person will have sustained too much damage or that cryopreservation will not be good enough is really only a concern over how long you have to wait, rather than a concern over whether or not we're ever going to get there.
Well, so you answered the question yourself when you said you don't know about a straight freeze, right? You don't know about, where the threshold comes. But it is reasonable, it's scientifically, biologically reasonable to suppose that there is indeed a threshold of how much damage is done by the cryopreservation process, above which, it simply isn't going to be possible to warm that person up and fix them up. That's kind of... Potentially, we could get that way with rejuvenation too. We could find that there were things that... were just impossible to fix. But I don't think that's going to actually happen based on the biology. But based on the cryobiology of cryopreservation, we simply don't know whether the kind of damage that accumulates today in someone who is not straight frozen, who gets proper M22 vitrification and everything, we still don't know whether that amount of damage is beyond the threshold of revivability, of the brain at any rate. And only further experimentation is going to answer that question.
You had said earlier, and I'm going to go back for a second because I want to challenge you on this because those were kind of fighting words to me. That in comparison to a young person, whether they should put their $50 into life extension or cryonics, and you said it might be a better idea that they put it into the kinds of things you're doing, and that's certainly a great place to put it. But in a previous video, you had said something about life extension having, among one of its bottlenecks, that it wasn't money but talent. And if that's the case, does that not suggest that right now the most bang for your buck is cryonics? If there's X amount of money going to life extension and a tiny fraction of that going to cryonics, why is cryonics not the better place to have an impact?
It's a good question. I think one could make that argument for people who don't have talent. But if you do have talent, then you can, time is money, right? You can dedicate some of your time, at the expense of earning more money, to contributing to the field that way. And most people do have talent of one kind or another that can be more useful than they often recognize, which is why I inspired the Less Death retreat series. So yeah, I mean, I think for some people your logic might be somewhat valid, but in general, I think if one takes into account that time is money, then what I was saying is broadly true.
And so I'm just trying to imagine, and it might be the same as it would be for a regular person. If you're speaking to some of these kind of life extension mega donors who trust you, they buy fully into the life extension mission. I just want to kind of get an idea in my head. How would you presume they would react if you told them in no uncertain terms that they should pivot to cryonics? I don't think you would say that, but I'm just trying to get an idea of how that would look.
Yeah, I mean, one thing that I have had to recognize over the past 20 years, even taking cryonics completely out of the question, is that every wealthy person is different. That, you have to do something that I find, it's not in my nature, which is to do 5% of the talking and 95% of the listening. And, you just got to find out where the path of least resistance is, the path that they will least resist. And, of course, there are a number of very wealthy people who have put money into cryonics. And most of them have not put money into rejuvenation. So, it's so emotional. It's like wealthy people do not make their decisions about philanthropy, by and large, on the basis of the kind of logic that we're discussing today.
Yeah. I mean, how much logic is there? So say you were talking to someone, would you change your advice based off their age? If you're talking to an 80-year-old, would you still be telling them your mission for life extension is most valuable to them, or would you say based off of their own self-interest, cryonics seems like the smarter route for them? They might not make it to LEV.
So the operative word in what you just asked is self-interest. The conversations that I have with high net worth people, very few of those conversations are with people in their 80s or even 70s. It's like quite remarkable how few people at that age in their life are interested enough even to get to the point of talking to me or me talking to them. And I believe a lot of that is because they have already made the calculation that you just said, that this is not going to be in time for them, whatever they do. And so certainly if I were, as and when I am, in a position to talk to people like that, feeling them out on the possibility of being cryopreserved is absolutely something that matters. However, one thing that often overshadows that, because it's an easier conversation to have because they've already decided that cryonics is science fiction, is to talk about altruism. In other words, to get away from the self-interest part. And to point out, and this is something, again, I've said many times in interviews and so on, that if you're putting a bunch of money into longevity research and you make a difference as a result to the point at which we reach longevity escape velocity, then you're saving a hell of a lot of lives. I mean, a hell of a lot. And it really doesn't matter whose lives, whether you're one of them. Last I heard, it was fairly fashionable to care about your kids, things like that. So, I try to push that as well, and I have remarkably low hit rate, but with that argument as well. It's like I say, this is not a logic thing. I wish it were, but it isn't.
It also seems to me that when people reach some age, 70s, 80s, they I don't know if this is built in biologically or what, but it does seem like people lose the will to live or lose the interest in life or such, maybe because certain brain changes, or just the fact that life isn't as interesting. Maybe the colors aren't as vivid anymore, something, but that people just seem to lose their desire. This happens to cryonicists as well. People who say that they're going to sign up for cryonics late in life, and they just push it off, and then by the time they're actually going to sign up, it seemed like they were really interested, but then they sort of lose the spark to continue going.
Yeah, I think that's driven by multiple different drivers, I think. First of all, there's the feeling that the loss of energy and vibrancy and general lust for life. Then there's the fact that one has been ground down by the things that didn't go right in life, and one's just become excessively philosophical, shall we say. And then the third one, which is very important, is being ground down by having spent a high proportion of one's life in the past, in the distant past, where technology was much less far advanced, and one's having trouble appreciating the rate of advance.
That, and also the death of a lot of people that they may have known, and a lot of the world that they knew sort of passing by. Yeah.
That's definitely another one.
Yeah, I mean, they've also had so much time under their belt to kind of accept death. And it's, so that's, insofar as their brain is concerned, that's a well-worn path.
Yeah, that's one aspect of the third of the things I mentioned, yes.
Is there any scenario you could foresee? And I'm probably being very obvious. So I certainly would love you to I know you participate in cryonics to a certain amount, but I would love to see you participate even more. So I'm making the case here. Is there any scenario you can see where you would regret not focusing more of your time on cryonics?
No, I don't think so. I mean, because I revisit constantly the impact that I'm making, right? And how I can make the most impact. So, for example, my transition to spending an enormous amount of my time on stage and on camera started in about 2005, 2006. And it was driven by the discovery that I was fairly good at inspiring people. Before that, I was basically just focusing on the science, and I was, discussing obviously things with my scientific colleagues, but I wasn't really trying to get out there. But I found that I was capable of bringing more and more people into the field, including very talented people, and so I felt that was the right way to spend my time. I guess it depends what you mean by regret. If you do something and you decide that it was a mistake, but the reason why it was a mistake was something you didn't know and couldn't have known at the time you made the mistake, then that's not really a regret in my book.
Well, let's take it away from regret and bring it to like a more plausible scenario that you could address like right now. So if tomorrow you came down with some type of rare disease, a slow moving cancer, you had 5 to 10 years of life left. Let's assume in the scenario that you're likely going to die of this disease. Do you stop everything you're doing in life extension and now devote all your time to cryonics and trying to bring as much into cryonics as you can before you die out of pure self-interest in this regard?
Not really, because I am overwhelmingly driven by the altruistic, the humanitarian side of things, as I mentioned earlier. And that applies to the rejuvenation and the cryonics aspects of what I do. So for me, the importance of hastening cryonics research and improving the quality of cryopreservation so that people have a good chance of being revivable in due course, that matters just as much to me, or 99.9% as much as to me, whether or not I'm going to need it.
Huh. I mean, now I just feel selfish because I don't think I would put those numbers on myself nearly as high. I mean, I certainly have the same humanitarian bent, but it's quite hard for me to believe that, your self-interest would be at at 1% over 99%. I don't know where I put the numbers for myself, but I do care enough about myself
I'm definitely in the minority here, but I honestly don't understand why I'm in the minority, because for me it's just math. Let's talk about rejuvenation first, right? So, I believe that my work has brought rejuvenation forward by a few years already, and maybe I'm going to be able to bring it forward by a few more. But what does that mean for me in terms of my likelihood of making the cut? Relative to, being too old anyway, and not making the cut, or alternatively being young enough anyway and making the cut even if I had spent my life on the beach or doing cryonics, right? It's a few percent. And, that's not terribly overwhelming, really. It's a bit underwhelming. Whereas if I, take into account that every single day that I bring forward the defeat of aging, I'm saving more than 100,000 lives, that's very easy to get out of bed for. And, to me, it's the same thing with cryonics research. If we're bringing forward the development of cryopreservation technology that is good enough to give people a fair chance of being warmable up, and if we decide that today we're in a that chance is much lower, even in the best case scenario, then again, it's the number of people that can be affected. And of course, that does very much depend on some of the questions we were discussing earlier about take-up. But as I say, my strong prediction is that the sea change, the tsunami of, well, that's not probably the wrong word, the tidal wave of expansion of cryonics will very much mirror the tidal wave and happen simultaneously with the tidal wave of rejuvenation.
Okay, so you don't necessarily believe you're sidestepping one for the other. You view your mission as just it will drag cryonics along with it, and therefore you essentially are doing cryonics without actually doing or without actually participating fully in it.
Yeah, kind of. I really don't like to think of it as not participating fully. For me, it's
bad choice of words. You are very active.
If I look at rejuvenation, right, it's a divide and conquer strategy, right? So you could say I'm not participating fully in mitochondrial rejuvenation. I'm not participating fully in lysosomal rejuvenation. Is that really a sensible way to look at it? I don't think so. I think all of these things is part and parcel of the same thing. The only real distinction is that the hastening of high-quality cryopreservation is saving the lives of different people than the rejuvenation stuff.
It does seem to me like as soon as we have, if tomorrow Tanya Jones or somebody else who's working on cryopreservation technologies makes a breakthrough, and we are now able to do organ banking or even the cryopreservation, and we can't properly revive an entire person, but we can do organ banking or such. I would imagine that cryonics there would be 3, 4, 5 orders of magnitude more people interested in cryonics than there are today, at least.
Yeah, I think it will be slower than that, but not much slower. I think that the irrationality that we've been discussing, the entrenchment of the view that death is death and there's no such thing as being like Schrodinger's death, that's very, very deep-seated. And I think that just being able to do this really well for solid organs, for other solid organs, will not be enough to persuade all that many people off the fence, so to speak, over the edge into believing that yes, this is absolutely going. It's within striking distance of working for the brain as well. They just think of the brain as a very different kind of organ. And it is a very different kind of organ, so we won't know until we do it, right? With animals whose cognitive function can be tested at a pretty fine level of granularity.
I think, yeah, of course that's accurate, but I maybe I have more I have more faith in the idea that people are making this argument about the how death is necessary or it's useful or whatever the case is, because it's a convenient argument when it seems to be inevitable, but when you start chipping away at that inevitability, then it becomes a less and less convenient argument to continue to tell yourself that story.
No, that's exactly right. That's what I've called the pro-aging trance. The compulsion to put aging out of one's mind relies essentially on the ability to trick oneself into thinking either that aging is a blessing in disguise, or that it's so fundamentally woven into the fabric of the universe that it will be forever off limits to medicine, or both. And to a large extent, the same kind of dichotomy can be made with cryonics. I just think that, for exactly the same reason that there's a lot fewer people in cryonics today than what there are in rejuvenation, it's even further, into that realm, because it doesn't even feel like medicine to most people, right? This feels like genuinely reversing death as opposed to reversing aging. Reversing aging sounds like something that might be medically plausible. Reversing death isn't. And I complain a lot about how aging and death are used interchangeably by journalists who want to, subliminally, entrench, and get people not to take the rejuvenation movement seriously. But in the case of cryonics, it really is death, so long as right up until you get to the point of actually taking the trouble to distinguish between legal death and biological death.
Yeah, if you want to see the textbook definition of poisoning the well, just read a typical journalist article on the subject of cryonics or life extension.
Sure. I mean, of course, it is getting better. There's a lot more respect for cryonics now than there was 10, 20 years ago, same as there is for rejuvenation. So, we can't, it's not all doom and gloom.
There's a question I wanted to ask that I think is you probably nobody as qualified to answer it as you, which is you have such a wide swath of knowledge about a bunch of different biological fields, and so I want to know: do you think cryonics and cryopreservation is an easier problem to solve than life extension or life extension escape velocity? Do you think by itself it's easier? I mean, you have these 7 different causes of aging, which are very complicated, and with,
so it's a great
with cryopreservation,
I get it.
You don't even need revival. Just if you do a proper cryopreservation, you have as much time as you need to learn how to do the proper rewarming. But yeah, is it easier?
So I think it's very hard to rank the two. Here's why. The rejuvenation side of things, we know very clearly that it's a divide and conquer problem, that there are many, many different types of damage that accumulate. It becomes slightly less daunting when we realize that we can classify those many, many types of damage into a relatively manageable number of categories, which is, of course, what I did 20-odd years ago. And that classification describes not only the damage itself, but the manner in which the damage could be repaired. So that it's generic approaches to doing the damage repair. So we inherently know that that's a very hard problem, because even stated in as optimistic a way as you can, there are still at least 7 different types of technology, that all of them rather difficult, that we have to develop. Whereas nominally, in the case of cryonics and cryopreservation, there's only one. We just have to figure out a way to vitrify tissues in a manner that does very little damage to them, over and above the damage, obviously, that they already have. And, of course, to be able to warm them up again without doing damage there. I'm sure you understand about the hysteresis there. So that sounds like just a unitary problem. But if you get into the details, of course, it turns out that it's all about chemistry and biology. So, there are, the same cryoprotectant, the same protocol may do very different types of damage to different tissues, for all we know. And, so the further we get into this, the more we may decide that actually it's of comparable difficulty. But what I will say is that, speaking as of now, there is a significant chance, a significant hope, that it will turn out to be a pretty unitary problem. That basically things that work in some places, for some organs, will work for all organs, as long as they work really well, and therefore that yes, it will actually turn out to be an easier problem.
And in some like examples of LEV, we all know technology almost will always trickle down to the masses eventually. And we should assume, I assume you would agree that the richest people will benefit from LEV at first. But in scenarios where, for example, there's, say for your 7 causes of aging, assuming no more are found, if say six out of the 7 interventions are affordable, but the 7th is, only affordable by the uber wealthy, is that a scenario you can see happening? In that case, would cryonics at that point become the poor man's life extension?
So thank you for asking this, because yes, absolutely, this is a very important question to answer. And it's not I'm not going to go the direction you might have thought. So in the case of rejuvenation, as you say, these technologies are, we don't know how expensive they're going to be at first, and some of them can be more expensive than others to deliver, right? And, the people who develop them want to make money out of them and so on and so forth. But the good news for rejuvenation is that the cost of not doing rejuvenation on people is so astronomical that at the level of national economic priorities, purely mercenary economic, even forgetting all the humanitarian imperative and all of the electoral imperative and everything, it's going to be absolutely inescapable that one should actually ensure that everybody who is old enough to need these rejuvenation therapies can get them, irrespective of their ability to pay. And how the money gets distributed, obviously, is going to differ from one country to another, depending on whether you like private healthcare or whatever. But the point is, one way or another, it's going to be done, because these therapies are going to, even if they're expensive, they're going to pay for themselves at the level of society enormously quickly, enormously many times over, just by stopping people from getting into that ridiculously astronomically expensive state of being chronically sick, which is, the destination of the vast majority of the medical budget of the Western world, and actually the majority of the budget of the developing world now. So, if we now move on to cryonics and we look at the corresponding question, it's a little less, in fact, it's a lot less clear, because there, if you're getting on and you think you might need to be cryopreserved, even if we take a permissive interpretation of where things are going in terms of elected suicide or assisted suicide or whatever, right? For as long as cryopreservation is viewed by society as a choice of how to dispose of human remains, rather than as a medical procedure for someone who is at least probably still alive, right? Then you've got a very big problem, because it's not actually helping. It's not actually going to be something that saves the country money. I mean, of course, one could argue that maybe you'll save the country a little bit of money by prematurely ending your chronic condition. But like I say, that rather requires a very permissive view of elected suicide. Therefore, I think really the only way that the same kind of logic can work in the case of cryonics is if you have some kind of general acceptance that cryonics is a form of medical care, a form of medically induced coma or whatever, right? And that people are, entitled and or, maybe even encouraged to take that option for a decade in order to benefit from improved technology in terms of rejuvenation. And that's a tall order. There were jokes about that in The Hitchhiker's Guide to the Galaxy, this guy who was spending a year dead for tax reasons. I'm not seeing that happening. I think that the take-up of cryonics in the scenario of a world where most people understand that rejuvenation is only, is within striking distance, and this is their only shot at it, right? The uptake of that is going to be predominantly driven by individual choice rather than by taxpayers' money.
One difference I would say here is that cryonics is something that happens at a moment in time. You want to be signed up prior, of course, for however long, but it's something that happens at a moment in time. So presumably you could, you don't need every country where every cryonicist resides to have this policy of allowing euthanasia for, what they would claim is euthanasia for purposes of cryonics. For example, if Switzerland itself wanted to do this, then a cryonicist who's particularly interested in having this procedure done could go to Switzerland and have that done, and it's done at a moment in time. Whereas policies that affect rejuvenation therapies, presumably those are going to be something that happens kind of continuously throughout a person's life once we start getting to those technologies.
Well, yes, that's certainly true. But of course, the idea of cryopreservation is that it should be temporary, right? So
right.
If we're in a situation in which someone can be cryopreserved with high quality and high confidence of revival, then you're going to want to revive them as soon as the technology to fix them up from whatever they became whatever made them want to be cryopreserved in the first place exists. Right, so
could be 100 years, could be 200 years. I mean, and the world may look very, very, very different.
Yeah, no. I mean, the point is that people will not, in general, want to make this choice unless and until they believe that the rejuvenation of what they're suffering from is really close. I think that's the point. At the moment, we've got. So this is coming back to what we were discussing earlier. If you're somebody who believes that longevity escape velocity is nowhere near as close as I'm saying it is, like a century or more away, right? And therefore you don't know whether it's ever going to happen, because we definitely don't know whether anything that we think is more than a century away is ever going to happen, right? If you like that, then your incentive to get cryopreserved is diminished. Because you know that there's not going to be any point in reviving you unless and until that rejuvenation technology is in fact developed, right?
Well, I assume at least for my own cryopreservation that if I were to be cryopreserved next year, I would be waiting a while, right? I would imagine again, who knows what's going to happen if we get some sort of runaway artificial intelligence, then all bets are off for everything, and et cetera, et cetera.
But that's not what we were discussing. We were discussing the idea of elective cryopreservation, right? So you would, as I understand it, you're not thinking of getting cryopreserved next year unless and until you get into
right. Yeah. Right, but of course, if I am diagnosed with some terminal illness or some problem like that, or if I get into my 80s, or something, and I'm seeing a substantial drop off in my in tests of my IQ or whatever else, I would say, all right, it's time. Go ahead and put me in, as long as it's legal anywhere in the world.
Sure. No, that's right. But you're already a cryonicist, is my point. We were talking about people who aren't. We were talking about people who are currently, considerably less far along that path.
Hopefully, a few of them are convinced by this. I had another a point though, which was when you were talking about funding life extension using traditional sources of funding that health insurance or whatever. It occurred to me that perhaps we can convince Medicare once these things start coming around that it would be beneficial for Medicare's budget to be funding these rejuvenation technologies. But as an additional to that, if that's not enough, you could say that anybody who is interested in these technologies, if they want it to be funded by the government, can forfeit either all or a portion of their Social Security here in the United States, which presumably, if they're not getting old and they're not becoming more decrepit, then the entire point behind Social Security, which was to make sure that the elderly people who couldn't work or couldn't, et cetera, are being taken care of. Well, if you never become elderly biologically, then what is the point of something like Social Security? So I would not have a problem with a policy that requires people to kind of forfeit that if you want the government to pay for these services.
Yeah, that's one of the possibilities. There's so many. I mean, and of course, we have to discuss this and think about it in the context of changes to the whole way that the economy works, consequent on automation. Even conservative organizations like the United Nations are saying that, by 2050, most of the jobs that exist today will not exist. And, perhaps sooner. The manner in which wealth is distributed will not be the same in a world where full employment is not the assumption. And as such, all of these things are going to be rebuilt from the ground up.
So our friend Eric Magro also had a few interesting questions. So he is particularly worried about the kinds of blockades to access that might still exist for the kinds of medical interventions that you're working on. FDA approval, other accessibility, et cetera. Which of these bottlenecks are you particularly worried about?
Honestly, it's hard to rank them. And for that reason, the Lev Foundation is trying to fight on a bunch of different fronts. So let's talk about FDA approval and the regulatory process, because there, things are definitely moving forward. We are putting money into a lobbying organization, a 501c4 called the Alliance for Longevity Initiatives, which is very energetic on Capitol Hill at the moment in terms of trying to influence Congress people and also in state legislatures. And that's particularly timely right now because literally tomorrow there's going to be a debate on a bill in Montana that is to extend the right to try concept. In other words, the access to medicines that have not yet been FDA approved. It went through committee successfully yesterday, so good chance. And this is the kind of thing that we definitely regard as very important, and that's why we are putting a bit of money into making it happen. Similarly, social fatalism about this that we talked about earlier is something that we feel it has to be addressed. And so we're funding an organization that I like to describe as the antidote to the AARP. It's called the Health Span Action Coalition. It's basically its main target audience is the older generation, but it's very much an advocacy organization that wants to fight for the human rights of the elderly, but within a context of optimism rather than fatalism as regards the medical aspect.
And so do you worry that let me ask, are there any interventions that are reversing age-related damage that aren't really targeting any specific disease or because my understanding is that the FDA will typically, you approve for a specific use case, a specific disease, but if you're not...
Yeah, we're okay there because even though some of them are harder than others to describe in that way when we restrict ourselves to diseases of late life, it's not nearly so hard if we look at diseases in general. Basically, every type of molecular and cellular damage that accumulates in the body and eventually makes us sick when we're old also accumulates at a greatly accelerated rate in this or that congenital condition, such that it's a proper disease of childhood. And so that's the standard way to get around the problem you're describing.
Got it. Also from Eric, do you expect, AI has been all the rage lately. Do you expect AI tools to have any meaningful impact on this field? Obviously, there's a problem of going from digital to, biological and all the problems there. But do you, in the next few years or something?
They already are. And
okay.
And of course, there may be some areas in which the problem of going from digital to biological is fundamental. like simulations, of how biological systems work. But in many cases, that's not required. So, AlphaFold is a perfectly good example. The program developed by DeepMind over the past few years that has more or less solved the protein folding problem. That's huge. It's as huge as CRISPR. It's as huge as the sequencing of the human genome. And of course, not only for longevity research, but for research across the whole of medicine. There will be examples like that over and over again. Also, examples of using, state-of-the-art machine learning to identify repurposing of existing drugs. Companies like In Silico Medicine, for example, are doing that. It's like, totally. There's plenty of AI already in this area. It's making a big difference.
Got it. So now we're going to move to the final segment, which we call overrated and underrated. So in this segment, feel free to take these relatively quickly, or however you feel. But tell us if you feel this is this particular subject is overrated or underrated. Okay, number 1, pet cryonics, or I guess pet life extension as well.
It has been underrated. And that's changing, both in cryonics and in life extension. It's been generally recognized in rejuvenation that this could be a really important avenue because, number one, you've got people really care about their pets. And so they're willing to even spend money to help to fund clinical trials on things. And secondly, the regulations are much less stringent when you're not treating humans. So that logic's been around a long time, but it turns out that purely technical, logistical aspects have turned out to be really challenging in terms of actually doing useful stuff that's informative. But that challenge has been taken on over the years more and more, and now we have a few very prominent researchers. Perhaps the most important is Matt Kaberlein at the University of Washington, who are really making a lot of noise in that area. So absolutely, I think in rejuvenation, this has been underrated, not in principle, but in practice, and that is becoming better. Similarly in cryonics, of course, pets have been cryopreserved for a long, long time. Of course, Kai Mills has now created a company that's focused exclusively on that. And I think that's interesting. That's definitely a very valuable way to go because it gives the whole concept higher profile. I think if you asked 99% of people who know what cryonics is but don't know much more than that, whether pets get cryopreserved, they'd probably say, "Oh, I hadn't thought of that," or "No," or whatever. But having a company that actually is focused on it is a step forward.
This brings up the question in my mind of maybe you can make another prediction, but do you think the average life extension therapy that is developed, rejuvenation therapy, is likely to be first introduced and used more widely in pets well before, maybe even a few years before it ends up being used in humans?
Yes, I do. I think that there's only so far you can go with mice. If you're working with an organism that is intermediate in size and in lifespan, then you can get more information. And so I think that is quite likely.
So the next one is stem cell banking. So there's this, for example, there's a company called Forever Labs, which does this. Do you think it's useful, valuable, or going to end up being not all that important?
Hard to say. So if you're banking stem cells from like umbilical cord, for example, I don't think there's any real prospect that would be useful for problems that the person would have in old age, simply because there's so much time that's going to happen between now and then, and therefore, so much progress is going to be made in creating technologies that will completely obviate the ostensible advantages of the umbilical cells. But of course, that's not the only reason why people do that. Another reason is to guard against the risk, which may be low but non-zero, of their child getting some problem quite soon, like some in infancy that could benefit from their own stem cells. So I don't think that's overrated. I think that's fine. in terms of whether one should bank cells when one is, let's say, 40 or 50, in anticipation of problems that they might be useful for a couple of decades later, that's the argument that I just gave is less strong because there's less time involved, but it's weakening all the time as we get better and better at manipulating stem cells and creating induced pluripotent cells and so on. So honestly, the jury is out on that one.
Got it. Overrated or underrated bioethics and bioethicists?
Grossly overrated. Honestly, it's very hard to understand why people can actually earn a living doing things like that. But basically, it's the same thing that you get when you make movies that make people comfortable. Like I often complain about how virtually all movies that describe a post-aging world are dystopic in one way or another, and they sell. Right, so it's the same kind of thing. Yeah,
we humans seem to have a love for that kind of
like I said,
sci-fi.
It's a case of wanting to reinforce one's inherently fragile ability to put aging out of one's mind and pretend that it's never going to change or that it shouldn't change.
Overpopulation as a problem.
Oh God, yeah, that's ludicrously over hyped. Yeah, I mean, of course, we have an overpopulation problem already today, but what people are worried about when they talk about it in the context of life extension is that we'll have a lot more people and we'll have to find room for. And the fact is, the overpopulation problem today is not about having enough space. Every single person on the planet could have their own acre without even going outside of the areas of the world that are comfortable to live in, right? So, no, it's all about pollution. And, of course, we're fixing that at the same time with other technologies, whether it's carbon capture or whether it's, nuclear fusion or whether it's, cheap desalination or bacteria that eat plastic or artificial meat. All of these things are coming. And so, it's completely crazy to think about the idea that we should somehow prefer to let people carry on getting sick and miserable and dead rather than that.
In these lecture circuits you do, you've given hundreds of these talks about this. I imagine that question, someone, kind of getting up there very smug with themselves and asking about overpopulation, as if they're going to stump you. How does that make you feel answering it for the thousandth time?
Yeah. People do sometimes start questions like that with the words, "Have you ever considered that such and such?" Which, and I've got fairly good at put down answers.
So, overrated or underrated, gerontologists and the field of gerontology.
Oh, I mean, I wouldn't say they're either overrated or underrated. They have their place. Essentially, the people that I assume the question is referring to are biogerontologists, people who study the biology of aging. And the real thing that I like to emphasize that distinguishes most biogerontologists from myself is that I think of myself as a biomedical gerontologist. In other words, I'm interested in using what we understand about aging already to design and develop new therapies that might help people to stay healthier for longer. Whereas a biogerontologist will typically describe themselves as trying to understand aging better, trying to get more knowledge, whether or not they think about the application of that knowledge as being part of their job. So we totally need both. I think it's fair to say that when I came into the field, there was a serious shortage of biomedical gerontologists. Too many people were just finding things out for the sake of finding things out. But these days, a lot of those people have become more translational, and so I think we have the right balance right now.
All right, and this next one is overrated or underrated. It's going to be a bit of a quote, but it's Elon Musk's idea, which I will quote, that it would cause asphyxiation of society. That if people lived indefinitely, it would cause asphyxiation of society, because the truth is most people don't change their mind. They just die. So if they don't die, we will be stuck with old ideas and society won't advance. I think we already have quite a serious issue with too many old people, where the leaders of so many countries are extremely old. So the sort of pro-aging trends. Elon Musk seems to be a fan of this, but how would you react to this idea?
Yeah, right. So, of course, first of all, I think it's probably wrong that, in fact, the more we rejuvenate people, the more we will rejuvenate them cognitively and get them more comfortable with moving with the times. But even if he's right, there's more than one way to address the problem.
Well, that is all on my plate. Daniel, did you have anything else you wanted to follow up with?
No, I just want to thank you for being here. This was a lot of fun.
Well, it's my pleasure. And you're right on time, because I have a phone call in 1 minute. Thank you so much. Great fun. And tell me, obviously, when it's online, and I will tweet the hell out of it.
Will do. Thank you, Aubrey.
Rock and roll. Bye-bye.
All right. Aubrey de Grey has left our virtual studio. And Daniel and I really wanted to have this conversation, since life extension space, the life extension space, and the cryonic space are so closely aligned that we share the same goal. It makes sense to have these conversations. And we do have somewhat different methods of getting there, of course. So obviously Cryonics is trying to get there, assuming that, in a sense, life extension doesn't work, or doesn't work for specific individuals in time, or something happens to that individual that causes them to check out sooner rather than later. But of course, even if life extension technologies do arrive in our lifetimes, they may be insufficient to keep us out of the cryonics tour in time. So even though we may get life extension technologies, we may not truly get longevity escape velocity for any given individual. And again, even if they arrive in our lifetimes and they are sufficient to prevent us from dying of old age, something else could happen to us that is not an age-related disease or an age-related source of trauma. That means cryonics is still very valuable. So even if you are interested in life extension, you should sign up for Cryonics. And of course, if you are interested in Cryonics, you should be very closely monitoring what's going on in the life extension space to be able to benefit from those therapies, since both of these fields share the same goal. But of course, if you have the talent that you can, or the money that you can devote to either space, it would be a question of figuring out where your individual talents can have the greatest impact, or where your dollars can have the greatest impact. So all of that is to say, life extension and cryonics are, two sides of the same end goal, the same coin. Daniel, what did you think?
Yeah, I was pretty excited in anticipation of this episode. In my personal journey towards cryonics, Aubrey was pretty influential. I would say pivotal in terms of getting me where I am now. I had like a 4-step process that landed me firmly in cryonics. Just briefly, first I wanted to increase my healthy lifespan, just because who wants to get sick and ill and such. Then I, eventually I wanted to increase my overall lifespan, not just be healthy for a short period of time, but actually live longer. And then finally, I kind of wanted indefinite life, and this is where Aubrey's book "Ending Aging" was pretty pivotal for me. It was a big jump, because I went from wanting a finite amount of life in these earlier steps to wanting an indefinite amount of life, and seeing a road forward for that. So that was really, really important step to make, and from there, I just kind of naturally led into cryonics, because I just didn't really believe the timelines, or I thought the timelines were too risky. But insofar as this discussion with Aubrey, try as I might, I could not get Aubrey to drop everything and devote the remainder of his life to cryonics. So obviously I need to work on my persuasion technique.
Yeah, you just didn't try hard enough, Daniel. That was
no. I thought I had him with the whole he's getting up there in age, and therefore he shouldn't he pivot to cryonics out of self-preservation. I thought that argument was had him in the bag.
No. He's stated several times. I've seen of several of his. He's stated many times that he's not really doing this for himself. Now, to what extent that's really deeply psychologically true, only he and maybe not even he would really know. But he has stated that even if he himself wasn't going to be able to take advantage of these therapies, that he would still be working on this.
Yeah, no, I didn't know how to respond to him saying that. And, that 99% about saving others and only 1% about his own life. It's kind of a hard ratio for me to believe, but I don't know. In any case, move over Mother Teresa. There's a new sheriff in town.
No, yeah, I'm glad he's signed up for Cryonics because, we hopefully he can. Whether or not he himself happens to take advantage of these therapies that he's been working so hard for, that when he gets back, he can take advantage of them, because certainly by then, we'll have solved the problems if we don't manage to solve them within his lifetime.
Yeah, absolutely. And there was one other kind of funny thing or takeaway that I thought was funny when in terms of him having to answer the question about overpopulation and how often he answers that from kind of smug people coming up there and be like, have you ever considered it? And I was thinking about the corollary for cryonics, which I have to answer often, which bugged the shit out of me, which is like, have you considered ice formation as a problem? And every time I hear that, I want to just be really sarcastic. I'm like, no, we never. 50 years of doing this with these bright individuals and cryobiologists and physicists, and we never considered the ice problem. Like what?
Ice.
Oh, thank you.
Someone take a note. Ice. Ooh,
yeah,
you're not going to write that one down. Ice formation. That could be a problem. Actually, no. The one I often hear that also bugs me is, what if the power goes out? Oh my gosh. Well, geez, never thought of that one. Somebody buy a generator. What if the power goes out? Yeah. There's some of this kind of stuff in every field, but no, actually the overpopulation one, I find it interesting because it betrays a lack of imagination, from people and sort of a lack of understanding of growth and progress, and the fact that it's not the number of individuals, but kind of how you're able to get them to cooperate effectively in a broader civilization, social network, whatever you want to describe it as, economy, of course. And if you can get them to do this effectively and efficiently, then the more people you add to the mix, the better, right? So each individual brings with them more than one individual's worth of new technologies and progress and all this. In other words, they pay for themselves, as you add individuals. And of course, if you have a much worse system, a much more backward system, then that's not the case. But that's how we're trying to pull so much of the developing world, or whatever they want to call it, the third world, developing. There's like a new term for it these days, but trying to lift them out of such a situation so that they can contribute more effectively to this sort of progress.
Yeah, absolutely. Yeah, but overall, I thought it was a great conversation. It's been a long time. I've really wanted to kind of get his viewpoints on cryonics to kind of round out my how I view longevity and life extension and cryonics side by side. So I hope others kind of got that takeaway as well.
Yeah, it was quite an honor to get a chance to speak to Aubrey de Grey on the Cryonics Underground podcast. As always, you can find links, and we'll think of a few interesting things to link to down below in the description. You can find a link to the Cryosphere, where you can speak to Daniel and myself, to Eric, who thank you very much for helping to get us a few excellent questions today as well. And you can participate in this conversation more broadly. We even we have a channel devoted just to life extension, of course. So find us there. And we will see you guys, or listen to you guys. You will see us or hear us on the next episode. Goodbye for now.